Are we on? Yes, we are. Sorry about that. I was so sure that, yeah, and then I didn't, and I forgot to. Hello, and welcome to my workshop. It's me, John Park. It's time for John Park's workshop here on a Thursday. Thanks, everyone, for stopping by. Thanks for hopping over to watch wherever you're watching from. We broadcast into LinkedIn and Twitch and the YouTube and Facebook and who knows where else. I don't know, we have a big list. And thanks for popping into our chats. We've got some people over in YouTube as well as our Discord. Those are our main chats, so go check those out if you're interested in chatting away. If you got questions, thoughts, comments, please pop on by. Hello over in the YouTube chat right now. We got Dave Odessa and Beatagraf of Delhagen. Hoi hoi. Over in our Discord chat, which you can get to by going to adafruit.it/Discord. You'll get an instant invite. You will join and you will look for that channel right there. That's our live broadcast chat channel. Hey, Andy Calloway. Hey, Thin Man. Blitz City DIY. C. Grover. Todd Bot. Hello, 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 hello. This is not live broadcast brought channel, Todd. Or is it? Well. What do we have here today? I've got a show for you. I've got some standard things. I've got a coupon code to share with you so you can buy some things over at Adafruit and save some money. I have a recap of my product pick of the week show from Tuesday. I've got a brand spanking new CircuitPython Parsec for you. What else? We're going to do a look at a new project. I teased it last week, showed the fritzing off on it, but I've got some code going and a little demo happening on my encoder knob sequencer, note sequencer. And I'm even contemplating doing a little bit of live coding using Claude AI. I hate that, sorry. I hate AI as a word. Claude LLM. Claude, very clever predictor of the next letter. But it's really useful for this type of coding, so I want to show you maybe adding some features to that, and we'll take a look at how that works and what my workflow is for doing that kind of coding. Und what else? We also have, I'll give a little bit of a product pick tool tip kind of thing. It's actually just something I find very useful that I should have had a long time ago and I got not too long ago, and I believe DigiKey carries it, so we'll do a mini, not so great search, a good search. I'll do a good search and see if DigiKey carries the thing I'm going to show you. Lars is back there on the phone, so don't disturb him. And let's get to it. So, hey, YennyScoo7 and Andy Calloway, thanks for popping over into our chat as well. And here is the first thing, the first event. That is a coupon code for you. Knobby. Why did that get moved over? Let me slide it over. Knobby. Hey, look, did you know this thing does automatic transitions? Whoop, it does. Knobby, Knobby, that will get you 10% off over in the Adafruit store today. So if you head on over to Adafruit, look for some new stuff that you want, some old stuff that you want. Check out some of your wish lists. Look at a project. Maybe head on over to Learn. Maybe you say, hey, I want to build one of these Nada typewriters. Well, I think other than the bell, you can get it all right here on Adafruit, and you can save 10% on it. You can hit this add to cart over here on the side. You can take a look at all of the parts and pieces there. Maybe that's what you want. Maybe you want to go over to the main shop and look at view all new products and see what we've got. Look, here's a new stepper motor driver breakout board. What's that one's deal? I don't know, but do you want to save 59 or 60 cents on it? Well, then use that coupon code. Knobby is going to save you 10% in the store. It's not good for gift certificate subscriptions or software, but it will work on physical goods that we can put in an envelope or a box or a bag or a sack, or just we'll put it in some wrapping paper and tape and maybe bubble wrap. I don't know. But if it's a thing we can send you, then you can save 10% off today using the coupon code Knobby. Just throw them in your cart, and then at the end in the coupon code slot, type in Knobby. Why the silent K? I don't know. Weird language, right? Yes. Andy Calloway asks, is Lars on the hotline or placing orders? Lars is standing by for your call right now. He can answer any questions you have, any and all. So the other thing I want to mention about the shop, if you head over to adafruit.com, and at the end of .com, you type in /free, F-R-E-E. That will show you some of the free stuff you can get if you spend a lot. So if you spend $99 or more in the store, you're going to get a free PCB coaster with the gold Adafruit logo on it. If you spend $149 or more, you'll get the free coaster as well as a KB2040 keyboard microcontroller, perfect for your keyboard and macro pad and game controller projects. And then if you spend $199 or more, you'll get the coaster and the KB2040 as well as continental United States free UPS ground shipping. So those are some enticements. You can always find out about those by just checking out /free at the end of the Adafruit URL. However, you don't have to worry about it, because if you do hit those thresholds, the items are automatically added to your cart and listed as free. So that you want to see that work? Let's do it in real time. Here, let's buy something expensive. Let's look in the store for, how about analyzer? Oh, I'm in Learn. Let's go over to the shop. Analyzer. Here, digital and analog discovery 2, USB, oscilloscope, and logic out. I'm going to add that to the cart. I'm going to view the cart. And look, right there, automatically it added the PCB coaster, free. And the KB2040, free. And I believe if I were to actually check out with this, I'm going to remove it so I don't accidentally buy that, we would get the free ground shipping in the US as a shipping option on the way out. So that's that easy. Wow, I never really noticed. This thing looks like an Xbox, doesn't it? That's a cool case they put on that. It looks like a sort of like an original Xbox logo. So that's some free stuff. Over in our YouTube chat, Danilo Eni joined. Hello. Thanks for saying hi. Thanks for popping by. And over in our Discord, we have some new people joining over here. David, WA90NY, hello. Thanks for stopping in as well. All right, so that covers that stuff. Next up, I want to talk about my show that happens on Tuesday. I promise I'll stop clapping right in front of my lapel mic, my lav mic. I've got the product pick of the week on Tuesdays on that show, which happens at this time, 4 o'clock Eastern time, 2 o'clock Pacific time in the US. I show you some product from the store, sometimes something new, sometimes something old, but always something good, and we give you a deep, deep discount on it, usually 50% off. Give you some demos, show you how to use it. Here is a recap from this week's product pick. Check it out. That's the product pick of the week this week. It is the Feather M4 Can Express with the @SamE 51 on one feather on the terminal block, 3 wires, and then the same 3 wires are running across this, I don't know, 15 feet of cable to another feather can, M4 can, right here in the back. They both have a potentiometer on them there that I'm reading for setting the neopixel color of the one on the other side. When I turn the knob on this feather M4 can, I am changing the colors on the neopixel ring back here on the other feathers. In the opposite direction, I can come over here and send messages back to the one on my desk. So traveling over 15 or 20 feet of wire, even though they're right next to each other, you can see it's very, very responsive. Product pick of the week this week, it is the Feather M4 Can Express. Because we can. Yes, we can. Right, so now what, you may ask? Now, let's dive into a CircuitPython Parsec. CircuitPython Parsec. Ooh, all right, let me open up that file. I've got a microcontroller plugged in here, and we'll get started. Okay, hey, check it out. On the CircuitPython Parsec today, I wanted to talk about moving things around inside of display I/O using the X and Y properties. So this is something you've probably seen before in a larger context, but I just wanted to drill in on how useful this is and how simple it is to use. What I have going on right here, there's a feather with a 0.91 inch OLED display here. It's a 128 by 32 pixel display. Cute little OLED, I love these. And you can see it's just plugged in using a little Stemma QT cable there. Got a little border on there, and then I have this little dot, this little letter O moving around the screen. You can see it moves one speed, moves faster, drops down, sort of like a screensaver or typing display. And the way this works is I have display I/O imported. I'm using terminal I/O for the simple built-in font, and I'm using Adafruit display text. I've got I2C display bus so that we can run the display right over I2C, using the SSD 1306 library for the driver on this board, release the display, set some pins, set the I2C bus that we're using, and then set up the display bus. We're telling the display the size and width and height we're using, as well as the size of that little border on there. Create the display right here using that bus, that width, that height. And then we create some contexts for this. We have the screen as the display I/O group, and then I'm adding some bitmaps and sprites. Finally, I'm drawing a text label. So here I'm initially setting it at a position, and then I'm creating the text here, O. We can change that easily. I'll show that in a second. And then we're creating a label. I'm calling it text area. We use the terminal font. We use the text that we've already picked. We use white in this case as the color. And then we set the X and Y positions, add that to the screen context. I've got a little variable here called speed. I'm setting it pretty fast, 0.001, and that is how quickly I'm moving from position to position. Here is the key thing. In the main loop, for Y in the range 8 vertically down to 24, in steps of 4, I'm setting text area.y to be equal to y, whatever that number is. So to move the text area vertically, all I have to do is set the property text area.y. Same thing with x. Text area.x equals, and then some number. In this case, I'm looping through values that start on the left at 2, move over to about the right. I don't want to go past that little border, so I go to 123, and then I go backwards. And when I go backwards, I'm incrementing, or decrementing in this case, by 2, so it moves a little faster. So if we go ahead and change a couple things in here, let's set a new, how about I'll use JP as my text and hit save there. So now you'll see the little letter JP moving across the screen, back fast, drop down, back, drop down. And so that is how you can move things in display I/O using the .x and .y properties. And that is your CircuitPython Parsec.
CircuitPython Parsec.
All right, and as a bonus danger, I wanted to get that done in the way I had planned, but let's go a little silly here. I got a snippet of code from ToddBot earlier, which is, I'm going to copy this here. We'll see if it copies and pastes okay. And I'll just paste it down at the bottom here, and let's take a look at this. So let's change our text area.x to be this little formula here. Text area x equals int 64 plus 50 times math sign times time monotonic times 10. And let me indent this here. Let's see what that does, if anything good. Could be something bad. Let's find out. Oh, and let me set the Y somewhere that we can see as well. Ooh, that's interesting. Let's open up the REPL here to see if it's complaining. I think it probably didn't like something I did here. Let's do disco tool n feather. Math isn't imported. Sure, that'll do it. Import math. How about now? There. It's very boingy. So thank you. Yeah, Todd over in the chat noticed that I hadn't imported math. Boing, 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 boing. Boing, 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 boing. Love that. Let's change the text here. Let's go back to the little dot. Boop. Here we go. Like a little ball. Doing, wing, wing. Super boingy. Let's do it. There we go. We can make it vertical. Ooh, I kind of like that. All right, thanks, Todd. So this is, once you know that you can move .x and .y, you can do some pretty cool little snippets of mathy algorithms to bounce stuff around your screen and move them in sine waves, other patterns, circles, etc. Some tips here. We can change the speed. Let's see. Very Pong, much bounce. All right, thanks for that. Let's, while we're here, in fact, I want to try one thing as a preview of some of this Claude stuff. So I'm going to open up a different screen here. Let's close this. I'm going to make a new Claude AI chat, and I'm going to say, give me a version of this code snippet that moves in a sine wave pattern up and down as it moves left and right. And I'm just going to give it that one little bit. And here Claude returns, here's a modified code that will move the sine wave pattern horizontally and vertically. So you can see we now have a text area x, and it figured out that text area.y would give us the up and down. So let's try that one, and then it has a little explainer on that, and it also says that we can do a synchronized version. So let's see if this works and how it looks. So I'm going to go back to my code here. Let me get rid of this chunk. Just comment that. Oops. Let me comment that out for now. Paste that in, and let's see the difference. Wow, okay, it's off the screen. So we might need to change some of these values. Let's do 16 on Y. So it doesn't go so far off the screen. Oh, I think we're getting, yeah, sort of a Lissajous kind of pattern. But let's try the other one, which said to sync these up, and we'll change the width and height on that as well, just to center it better. So let me come over to Claude here. By the way, I'm using this sort of in the most simple way, which is asking a question, getting a code snippet, copying it, and pasting it. On this machine here in the workshop, that's as far as I have it set up. In my studio, I have it also set up to be able to write files in a little sandboxed area, so I can have Claude actually save out files for me on disk, which I then copy over to the CircuitPython board. I don't want it saving directly to that board. So let's change this to 16. Let's do this to 32. And let me hold this up a little bigger. Ooh, hey, all right, so it's kind of doing a little, is it just diagonal? It's hard to see. Let's go to 8. And so what I would do is maybe try tuning it myself here, but then I'll come back to Claude and say, the screen is 132 by, or sorry, 128 by 32. Please keep the text inside these bounds. And here it'll say, here's the adjusted code. Okay, so it dropped it to kind of halves, 64 and 16. Let's see if that actually works. Yeah. Yeah, we definitely have sort of a figure 8 type of thing there. So pretty cool. Yeah, that's a sort of a preview of how we'll use Claude to get some interesting code very quickly. All right, so thank you, Todd, for that code snippet and inspiring that little journey there. All right, and let me know in the chat if you have other favorite sort of movement algorithms that are worth sharing or trying out. Let's see, next up, let me check, I don't think this guide is ready out of moderation yet. So I just want to let you know I have written up the LED shoes, dance shoes guide. I put out a video that you can check out on our YouTube channel. Just a simple action video. I'm going to get them into the hands of my friend and try to get a real performance with them. The Learn Guide should be coming out soon. That's in moderation now. And I did a couple of versions, which I showed last week. A simple one that just uses a battery bank, and then a more complicated one that has a Power Boost 1000C charger on-off switch, sort of a remote for the charging cable, so a little more sophisticated version. You can build one or either. I have actually one shoe as one and one as the other, and they work together perfectly, both using Sparkle Motion minis. Excuse me. In fact, let me go grab the video. I'll go to our YouTube and I'll just show you it from there. 1 second while I hunt that down. There we go. So here you can see they are doing some sync to each other as far as the patterns that are playing. Any changes to the boss one or the sender, the receiver will pick up. And then they're both doing audio reactive with the microphone built in. So that's them in action. You can go check that out if you're interested. And the Learn Guide will be out soon. All right, next up, let's do my little miniature good search. So let me show show the thing first, and stop me if I've showed this before. I don't think I have. This is one of these Menda pumps for fluid dispersion. This one says for isopropanol or IPA. You can get them where the plastic is made for different things, so acetone or other more corrosive things. They have different plastics that deal with those and different colors. But these allow you to have a what is essentially a closed bottle. This is not going to evaporate right now because there is a valve pump here that seals it off until you press down. And there you saw it spurt out because I pressed it kind of fast. Normally it'll just push a little, like 1/8 of a teaspoon of fluid up to the top. And then if you have wipes of some kind, pick that up and then go clean whatever. This is great for when you're soldering, if you need to quickly one-handed just push down on it. You don't need to close this lid. I just leave it open like that all the time. Grab a wipe, tap it in there, clean a thing, throw away the wipe. Really great. So this one, let me see if I can find that one on DigiKey. Let's go back. And I'll bring that up. So Menda, M-E-N-D-A, is the brand. And bottles, syringes, dispensing equipment is the category where I think we're going to find this. We might also just find it a little further down or use more search terms. Menda, bottle, pump. Yeah, so dispensing equipment. Let's click on that. So manufacturer is going to be Menda, and let's do bottle. Apply all. That gives us 8 results. So here you can see, here's the 8 of them. HDPE plastic is what this one is made from. I don't know if they have the blue one there. It looks like they have a yellow one here. I don't know if there are options once you drill into it. But there's one Duraplastic Menda. So I know that there are inexpensive alternatives out there. These are usually in the $20-something range. They're not cheap, but I've never tried the cheap ones, and the people who I've seen review them and try them say they're awful for the most part. So maybe your mileage will vary, but these are the real Menda brand ones. Oh, there's a little twist lock, different type, but you want these this pump top on them. And then they just have them in different sizes. There are some in bulk, some individually. So that's my little tool tip. These things are great. You will see them also in nail salons. Often use these as a quick, easy dispenser because they're actually spill-proof. So although I have a little still floating around in the top there, so I'm not going to dump mine over, but they are, unless that pump is pressed down, they are spill-proof. So I recommend those. That is my little mini tool tip. All right. Yeah, in the chat, Todd reports that the cheap ones suck. I've got a small and medium, the blue Menda dispensers for IPA, one for soldering, one for 3D printing. I've had them for over a decade. Yeah, that's impressive. They're durable. You can buy them for life. Thanks, Todd. Okay, let's see. Next up, let's take a look at this new project over here on the bench. So I showed the little. I'll talk about it for a second, then go demo it. So I showed the fritzing for this last week. What you can see on screen there, I have a QT Py. That's a QT Py RP2040. It is plugged into a USB-C cable, which is then running over to that synthesizer sequencer sampler thing, which is called the black box, 1010 Music black box, which is a USB MIDI host. So it's acting just like a computer. You could plug that QT into a computer and run synth software. In fact, I'll probably do that when we demo it here on my workstation as we adjust the code. But right now, that is getting power and then sending USB MIDI data up to the black box to tell it to play notes in different pitches, one note per knob that you see there. And then that is two of the Seesaw quad I2C rotary encoder boards, which happen to have little LEDs, neopixels, underneath them. Unfortunately, we have Lamore has been going back and forth for a couple years with some different factories about getting clear shaft encoders so that we can shine that light up through the shaft. So for right now, you won't see them unless you do like a light pipe. I know Liz did a project where she 3D printed a little riser that would diffuse some of that light, which is a really smart solution. For this, I'm actually going to put, I think, a neopixel strip across the top. They seem to line up. I think every third one lines up with a knob, so I may do that, or you could come up with another LED solution. And that's to show which steps are active as the time marches along. It's a timed step sequencer, as well as setting different colors for mute or unmute on a step. The thing about this is I'm intending for this to be modular, so I'll probably start with a 8 or 16 step, so 2 or 4 of these boards. I think that may be close to the limit of these with I2C addresses, but I could be wrong. You might be able to do more of them. We'll take a look at that. And you could also use a second I2C bus on boards that have that, or use an I2C multiplexer to be able to do 32 steps or 64 steps, however long you want. So let me demo it now. What I'm going to do is I've got, you can see this one purple lit note there. It's a sampled bass that was sampled. I think it starts at C sharp, but you can adjust that. I'm going to then take that note and play it at different tunings or different note values, just starting from that initial sample. This would work fine. It doesn't have to be samples. It would work fine with synthesized sounds as well. So let me head over there and we'll take a look at that and listen to that. I'm going to turn off that AC so that I can hear things better, and maybe you can too. And I just have this plugged into some little powered speakers over here. So I'm going to turn those up and you'll hear it just playing a sequence. There it goes. I'm going to change the first note here. In fact, let's set all these to the same note. Or not. I think I got my encoders off. You can't really rely on indicators on encoders because they spin around multiple times. But now we'll take some of these notes out by muting them. So I'm clicking first note, whoops, fifth note, first note. And so if we raise this first note, now we'll add in every other note. And we'll add in 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, rest, 5, 6, 7, rest. get the idea of how that's working? This is all just a single sample that it's playing with MIDI. We can, in fact, let's see what happens if we give that a different sample. I'm going to turn off more of these notes. What you can see under here is these two notes that are playing. You can also see the little pale red, I think. You can see the brighter red and the green on these. So if I illuminate all four of these notes. So let's just have two notes. And I'm going to go into the settings on here for this pad, and I'm just going to turn off the MIDI triggering for this. So MIDI in, none. Then if we come back out to pads, all right, here's a little sample of kind of a choir. So we'll go into this one, configuration, MIDI note in from channel. And by the way, I should ask, can you hear that? Because hopefully you could. I know it's just picking up on my lav mic. I'm just going to turn on the Discord so I can keep track of comments. 8 boards. Thank you. Thin Man says you can chain up to 8 boards on these. So there you go. That's how it works right now. And what I wanted to do is, let me unplug this from here, show you what the code looks like on it right now and see if we can add or adjust to the features on that. So we'll leave that alone. Maybe we'll come back to that, or we'll just test this on a software synthesizer over here. So let me come back to the bench, and how about go to this view of the world, and let's get this camera zoomed out just a little bit so you can see at least if I'm modifying stuff. So I'm going to plug this in. This will be a chance to get a little better look. In fact, let's go close up for a second. A little better look at the lights on here. So this is, turn on all steps. So there you can see we've got the sort of playback tempo running through there. It's allegedly 120 BPM, although I've come to mistrust timing sometimes in CircuitPython. Maybe this is handling it. One nice thing here is that we're sending very efficient messages over I2C to the board and back. So if things change, we get a very efficient message back with the state of buttons and encoders here. And then we're also sending a single message over I2C in the other direction to adjust the NeoPixel LEDs there. So let's do one other thing. I'm not going to show this, I think, but I will. Yeah. Let me. I'm just in the background here. I'm going to set up a. So here's a synth, software synth running now. Let me pick a slightly nicer. Nicer sounding preset on it. The one I'm using is called Helm, H-E-L-M. It's a free and open source mono synth. I think it's mono. And I could be wrong on that, but where the heck? I'm trying to remember how to. Ooh, these are arpeggios. We don't want that. Let's go to bass. Ooh, no. How about keys? Sure, slightly detuned bells thing. I like that. So, done there. So I'm just going to mute this for now, and then we'll look at changes, or we'll listen to that as we make changes. Let's see. So I'm going to go back to my code view here, and I'll open this code.py that's running on the little cutie pie. Okay. Oh no. Why is that opening? That's mysterious. It just reopened. That's funny. It has the CircuitPython Parsec code. Sorry, yeah, I also have the Claude. Let me switch the Claude over so you can get a sneak peek at that. Let's go to step sequencer. I'm just going to copy it out of here because for some reason my code.py has shown up as the CircuitPython Parsec code, even though I have a completely different microcontroller plugged in. Okay, so I'm going to paste this in. So I'm coding in that little middle window there, Z. This is it. Yes, this is the step sequencer. Okay, so I'm going to save that to this board. Replace. Okay, I'm going to turn the sound back up on the synth over here. Let's see if we're still getting. Oh, what did I crash? Oh, I crashed Z. Uh-oh. Yeah, Z got unhappy there. Let me reopen the file there. Okay, and let's turn on a couple notes. Okay, good. So that's working. Yay. So let's see. One change I'm going to make. I won't do this on camera because it'll be difficult to. I think it'll be difficult for you to see, but I am going to. Right now, if you listen and watch this, it does not make sense to me. It feels like it is changing the LED off by a beat. So let me turn this back up, and if the lag isn't too bad, you'll see with me. So it's boom. It actually, the red LED leaves this one. Yeah, so there's something I don't like about that display. Let me turn on all notes. Yeah, it's off by a note. So actually, yeah, why don't we try that? Let's see if we can change that. I'm going to mute this. So I'll come back over to Claude. I'll say the red LED indicating note on for current step seems to be lagging by 1 step. Let's see how Claude deals with that. So over on the right here, it uses what they call an artifact. and it's been versioning those. So you can see this is version 13 over here. We can go back through the different versions that I started on this, but it gives me a nice separate code display versus the chat itself. So here it says, you're right, the issue is that we're updating the display after advancing to the next step, so the red LED shows up on the step that just finished playing instead of the one that's currently playing. Let me fix the timing. So I like that. It means that it kind of understood, kind of rephrased my request back to me. This right here is a link to this artifact on the right in case this gets closed. And then it says, perfect, now the sequence is advanced to the next step. Current step gets updated first. Update display, LED shows the correct current step. Play current step, audio plays for the step that's visually indicated. I may correct it and say, well, MIDI message is sent, not audio is played, just to keep it from veering too far off in conversations and comments, but I'll leave it alone for now. And it says this ensures red LED accurately shows which step is currently playing with no lag. Visual and audio feedback are now perfectly synchronized. Well, so it says. Let's find out. So I'm going to just hit copy over here, come back to my code window. And the nice thing here is I'm not even worried about version control or backing it up, because that Claude window, as long as I assume the internet doesn't go away or Claude doesn't disappear, it has the versions. When I start changing the code myself, maybe I'll mess with comments, rename variables, I'll give that back to Claude and say, okay, here's my current version, and then I'll ask for whatever my next request is, and that way I incorporate any changes I make. So let's delete that, paste that in, hit save. And I'm going to open up the REPL, because sometimes errors are introduced at this point, but it looks like it's running at least. So I'll do disco tool qt, and here it's running steps 1, 2, 3, 4, 5, 6, 7, 8. Okay. So if I go and change one of these, and we're not listening to it at the moment, if I change one, you'll see, okay, step 1 is now on note 60, 62. So these are whole note scale MIDI numbers is what we're seeing. So bump, 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 bump. But that's the scale that's just kind of built into it initially. So let's turn this up, and here, what it's going to play when I unmute these. So right now you can see none of them are green, so we're not playing any. Oh. Yes. Right? Lowest note, bum. Bum. Yay! So the red LED now makes sense to me. Whew! Because that was driving me a little nutty. Now, here's something else I don't like. When I change a note, we're hearing a preview that's kind of out of time. It means it's sort of playable, but it's not what I want. I just want to hear that step when we get to it. I don't want to hear a live preview of that step. So I'm going to mute this again. Let me come back over to Le Claude, and I'll say, by the way, I don't know what this story was about Sam Altman saying every time you say please and thank you, you're adding to the computational waste of the thing. So I don't know. I was in the habit of being a little more polite. Now I'm trying to say less. So I won't thank it. I won't tell it that worked. It just kind of assumes that things work. It's very confident that way. But now I'm going to say, I don't want to hear a note or send a MIDI note on message. Here's me starting to course correct the way it's thinking about things a little. Play when I adjust an encoder only when the playhead reaches that step. So let's see what it thinks. Good point. The preview notes can be distracting. So preview note, that's what I should have called it. I don't think I used that word. This is one thing I think these LLMs do really well, is because they're tend to be so well trained on, in this case, really well trod ground. People have made code for this kind of MIDI stuff, written about audio preview, playhead, all that stuff. So it gets a lot of the terminology right, and I like that. So good note, the preview notes can be distracting when you're programming a sequence. Let me remove that feature. Perfect. Now when you turn the encoder to change note pitches, you'll only see the console output showing which note you've selected. The actual MIDI note will only play when the sequencer's playhead reaches each step during normal playback. This makes programming much cleaner. You can adjust multiple steps without hearing a bunch of random notes. You only hear your sequence when it actually plays through. Great. So let's copy, let's paste, we'll save, it'll restart. I can check the REPL to make sure. Cool. We're playing at 120 beats per second. It tells me what the Andy Calloway says, you don't have to be polite to it, JP, it's just a machine. Thank you. Okay, so let's go ahead and unmute some notes. By the way, at this point, what I would probably do is, and I'm going to get it to explain this change code-wise, because I don't want to go too far without knowing what it's doing. I'll look at the code, I will maybe comment some of it myself, and maybe make some changes without going through Claude. Like, I think I want all notes to be on at start instead of all muted, so I may make that change, and I may do that to the code myself, just to keep aware of it, because this is simple enough code that while I'm getting Claude to write it very quickly, it's not so big that I want to lose sight of how it works. So let me go, I've unmuted here, I'm going to go turn the sound back on my synthesizer software. And now I'll adjust a note. Great, so the first note is higher. Bum, 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 bum. And I'm not getting that distracting preview. Let's mute a note. Okay, I think it's not muting very well. Let's see. That muted, that muted, that muted. I will also check my soldering, but soldering looks good because there's 2 pins here that are the switch for the encoder. Could my knob just be pressed on? Oh, now it turned. Yeah, it could be that I might have to tighten that little knob screw, and I'm not actually pushing the thing down when I think I am. Okay, that could be it. I don't think it's code. All right, so hopefully you get an idea there of what that process is like. Let's come back here and say, explain how you made that change. And it understands that kind of a context. Great question. Here's exactly what I changed and why. The problem, in the handle encoder input function, there was this code block. Play preview note. Pretty self-explanatory. MIDI send, note on, the step ID note, and then the velocity. Time sleep, MIDI note off. So this always sends the note and turns it off. So it's a step, not a sustained thing. This code was executing every time you turned an encoder, which meant note on message sent immediately when encoder moved, 5 millisecond delay, note off message sent to stop the preview note, I should say. I was not saying that right a moment ago about this. So this is not during a step, but this was during the preview. The fix, I simply removed those 3 lines entirely. Woo! Now when you turn an encoder, the function only calculates the new note value, updates the step note property, prints the change to the console, updates the encoder position tracking. Why this works better: no unwanted MIDI traffic, no audio interruptions, cleaner workflow, still get feedback. All right, good. So that's a nice explanation of that. That's how I usually would go about this type of change if I'm not sure what changed. You can also do diffs. I don't know about doing them in here, but you can just use any diff software so you can see where the changes are. It may do that. I haven't asked. Sometimes Claude AI can give you different visual feedback of how things look. I like this current setup, so I'm not messing with it, but at some points it was doing more elaborate artifact windows, which I didn't like. So I like this little right side one. You can close it, you can reopen it here, you can track them and reopen them from inside of here, or you can go through your versions up top. And it seems to maintain history of this, so I can go into my little sidebar there and find that at another time. Let's see. Toddbot says, it'll be interesting to see how bad the output Claude and others generate once they get retrained on all the code they're generating now. I suspect it'll like making a Xerox of a Xerox of a Xerox of a, yeah, exactly. I don't have the knowledge or background to sort of discuss the bigger topic of, is this A, ruining the planet, B, ruining coding, is it polluting the whole pool as it trains from itself? I feel like maybe we should have thought about some of that before we just threw it all out there into the world. Like maybe AI generated code is tagged as AI generated code and it doesn't train on itself, but too late for that. But this is a huge, you know, if we take a look at this code, let me close this here, go back to that view. This is 200 lines of code that work really well, that are, I should say, initially I fed it some sample code of real examples from our Learn guides. So I gave it a very basic, here's me using an encoder, quad encoder, seesaw, Steno QT breakout. This is what it looks like to read that. So start from that so that it doesn't just kind of go wild at first. So I got that, and I fed it some basic MIDI examples of sending USB MIDI code out. So you can kind of point it at some hints to get your code the way you want it initially. But it does a lot of things very efficiently. You can see like it's got these one-liners that are setting up, you know, 4 different sets of encoders all on a single line. If I wrote that myself, I would probably have a little loop. So it does slightly optimize the code, maybe more than I like for Learn guide type of code. But I could probably tease that back out as well. Here you can see it just came up with using a pentatonic scale in C, because so many of the Adafruit and community CircuitPython MIDI projects already do this. So it said, yeah, I guess people don't just want a chromatic semitone scale, they want some whole notes so that it sounds good, or they want to throw in modes like Lydian and Ionian and what have you. In fact, that's something we could do right now. If I just let me bring Claude back up, I can say add standard scale modes with a user variable to pick one. That should be enough for it to go and say, okay, I'll add support for multiple scale modes with a user variable to select them, so give you much more musical flexibility. You can see over on the right here, it's adding pentatonic major, pentatonic minor, major, Dorian, Phrygian, Locrian, Ionian, yada, 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 Lydian, probably Mixolydian. So it'll go through and find the stuff that has been done before. Also, it's got the MIDI note numbers and commented over on the side the names, which is really nice. That is a lot of busy work that I would be disinclined to do if this were my hand-coded stuff. So here it's making edits. It's interesting because sometimes it will head down a path and then find an issue and go back and change stuff. It'll realize, oh, I just coded myself into a corner. I'm going to undo, and you'll see some code disappear and then reappear. So here's what it says. Perfect, now you have access to 12 different musical scales and modes. I added these: pentatonic, major and minor, church modes: major, Dorian, Phrygian, Lydian, Mixolydian, minor, Locrian, specialized scales: harmonic minor, melodic minor, blues, chromatic. That's cool. We could probably, before I even test this, let me add some more. I'm going to say, please add non-Western scale modes also. And I don't think this would have any impact to not test that one, because I think all it's going to do here is throw in a few more. There's not much that's getting changed. So after this, I can test. Let's see. Interestingly, since I gave Claude AI, and this is Adafruit has like a business account, pro level account. I don't know if this is a feature in the individual account, but I told it is allowed to search the web for stuff. So you can see, after I asked for that, it went and looked for a whole bunch of websites. Oh God, one of them's Quora, globalmusictheory.com, Stack Exchange. So you can actually look at academia.edu, Wikipedia. So it looked up Arabic, microtonal, Turkish meqams, Middle Eastern modal music, raga scales. So now over on the side, well, it's still going, so we'll let it finish and then it'll probably summarize that. Andy Calloway gave us the pentatonics there. Is it still going? It is. Yeah. I can't see its changes. I don't know why I'm not seeing the... I can tell it's moving around in the artifact, but I won't bug it. It's adding in more and more of these. You can, as of a version or two ago, you can stop it, which is nice. You can stop the Claude response and it kind of goes back to the previous artifact, and then you can say, whoa, 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 I can tell you're headed off into a weird direction. Okay, here, perfect. I've added a comprehensive collection. Now we've got Makam Rast, Makam Hijaz, and on, Sabah, Indonesian, Gamelan, Japanese scales. Heck yeah. Okay, so let's try this code. Let's come back up here. Copy. I think I made the window a little small, and so my copy button disappeared. And let's go back to that view. Go look at my REPL, paste, save. Cross fingers. Okay, so it has added them and it's running. Let's see how we pick them. And it might have had that in the summary. Scale mode, it says it twice, and I don't know why. So that's something I would probably just delete one of these and paste the code in for the next thing rather than try to tell it, oh, you made one line error. I'll probably just change it myself. So let's try Raga Kafi, folk-influenced raga. Where is that? There we go. Okay, let me turn on these notes. Yeah, it's definitely the sliding caps on my encoders that were not allowing me to unmute stuff. Okay, so those should all be playing. Let me turn up the volume. I think that just reset my board for some reason. Okay, so you can see here it was just playing previously ascending scale, but now it's this different different mode, so that's kind of cool. Really cool. So this could be a really fun way to explore some different non-Western scales or Western scales, and it might be interesting to adjust the interface. Oh my gosh, I can't mute that one note. There we go. Adjust the interface to allow you to pick scales either on the fly or on startup. I'm a fan on some things like this of just having a moment during startup where you can make some selections. Having a display alters things. A little OLED display off to the side might be nice. So that's the plan with this. I'm probably going to turn it into like a long strip, maybe with 16 knobs. I'd like to keep it long and skinny so I can put it like right in front of my keyboard and be able to play software synths with this little step sequencer. So that's the process there I'm using, coding that with Claude AI. I hope that was informative. I hope that didn't send anyone into a rage. But discuss if that's rage making. I'd love to hear about it. Last thing I'll do is remind you, if you want to get some stuff, maybe some Knobby knobs, that's your coupon code, Knobby knob. Now you know why, KNOBBY-KNOBBY. That will save you 10% off in the Adafruit shop today. Head on over there, buy some cool stuff. It's what keeps the lights on. It what allows us to keep doing the things we're doing, make learn guides, create cool boards, write software, open source, all of it. So please consider going and getting some stuff, but save yourself some money. Also, I wanted to recognize and wish people a happy Juneteenth today. And hopefully some people took the day off to celebrate that. What else? That is it. I will be back next week. I think we'll have Foamy Guy with a deep dive tomorrow. Possible Desk of Lady Ada types of things over the weekend. I'll have my Product Pick of the Week show on Tuesday. We'll have a 3D Hangouts on Wednesday. A Show and Tell should be back on Wednesday. We weren't able to do Show and Tell or Ask an Engineer yesterday due to illnesses and such. But yes, they'll be planning for a Show and Tell and an Ask an Engineer next Wednesday and more. So thank you all for stopping by. Thanks everyone over in the chats. Milp Mop, who joined, hello, over in YouTube. And everybody over here in the Discord. Thin Man asks, so you're using a paid subscription of Claude? That's right, that is a paid subscription. Adafruit has a business account that a number of us are using. I was using an individual account that was also paid before that, but the Adafruit one has greater power. It's an industrial strength one. And I think that mostly has to do with your caps on how many interactions you can have before it runs out of juice on your account. Okay, thanks everyone so much. That's going to do it for today. For Adafruit Industries, I'm John Park. That's Lars. He's still on the phone. This has been my workshop. I will see you next time. Bye-bye.